Hi guys, so this is my first video on engineering models and I hope you will watch till the end. Before just proceeding, I want to add a disclaimer that please use uh, headphones. Yeah, please use them actually. So, before just proceeding, I will just like to tell you the type of contents I will be covering in this module. That is the composition of air, diffusion of the gases, system boundary and the surrounding, thermodynamic parameters, introduction to the air compressor, working of air compressor and tracking the motion of the particles. I will be using my own created CAD models for the great demonstration and assembling of the prototype. So this is a clear-cut model or clear picture of the old type of air compressors used in the ancient times. In ancient times, the people used to use them in their firework stations, in their chimneys, or for their cooking styles. This is a clear and old-fashioned bellow picture. You can see that they use a valve for the entrance of the air, a nozzle. This works actually when compression or expansion of this bellow takes place. When the bellow expands, the air rushes in through the entrance valve, and when the compression takes place, the air moves out from the nozzle. So these work in the similar way as lungs. The lungs works in the similar way as the air compressor. So we can say that lungs are the natural air compressors. So when the lung expands due to some of the muscular forces, the air rushes in. And when the lung contracts due to the muscular forces, the air rushes out. So what is air? Air is just the mixture of several gases that can be nitrogen, oxygen, carbon dioxide, hydrogen, H2O, helium, neon, argon, krypton, etc. And these gases are in turn made up of many of the molecules, and molecules are in turn made up of many of the atoms. So if we take a look at the molecular or the microscopic level, we will find that nitrogen comprises 78%, oxygen 21%, carbon dioxide less than 1%, and H2O, helium, neon, argon, they are just in the minute levels. It was found experimentally that the mass of the constituent gases in air is 5.6 into 10 to the power minus 26 kg, which is very less. So if we take a look at these gases at the microscopic level, these gases are always in the random motion, moving here, here, and there. It can be like explained because there exists some kind of force which is responsible for this thing, and this force depends on weight, the size, and the shape of these particles. And this force is commonly, popularly, and universally known as the van der Waals force. There can be another type of force, which is the dipole interaction, which is just the interaction or the attraction of the positive and the negative charges that gets accumulated over the molecule or the atom. If I want to define it, I will say that every atom has an electron cloud where the electrons exist in differentials. That is true. So when the protons of other molecules come near the parent atom, that is the atom I'm talking about, then the electrons of the parent atom shift towards the proton. This is known as dipole formation, which is responsible for the attraction between the molecule. So if this atom moves near to this atom, the proton will attract the electron, so negative charge get accumulated over here and positive get accumulated over here, and this will result in some kind of attraction. This is the dipole interaction. I will talk about now diffusion of the gases. Diffusion is the property of gases. The particles tries to move from one place to the another due to the molecular forces. Like a perfume smell slowly spreads to the whole room. This is because of the air particles tries to move or diffuse from one place to another. This diffusion is dependent on the mass of the gas molecule. It was found out that this diffusion of gases is directly proportional to the minus power of mass, or I will say that this diffusion, that is the distance covered in the particular time, is inversely proportional to the root of the molar mass of the gas, where the K is a proportionally constant that mostly depends on the physical condition, and M is the molar mass of the gas, which is a natural driven process. Yes, this diffusion is a natural driven process, but this can be accelerated actually via change in parameters that can be temperature or pressure. Now we'll talk about some thermodynamic parameters. The typical type of air compressor we are actually assembling in this module is based on most of the thermodynamic parameters. This I wanted to define to you that thermodynamics is a study of heat or the energy interaction across the boundary of the system. Before just proceeding, I would like to want to tell you some of the terms we will be using further. This is the system, the boundary, and the surroundings. If I want to just tell you, the system is anything on which the thermodynamic study or the energy study is done. Boundary is any layer that separates the system to the outer world, and the surroundings is everything other than the system and the boundary. Now, for this, we will like to tell you, or I would just like to make you familiar with this CAD model. In this CAD model, I'm just telling you that system is this cylinder arrangement. This volume is the system volume, and this cylinder glass is the boundary, and everything outside the cylinder is the typical type, or I will say is the actual surrounding with respect to this system. Now moving to the presentation again, I will like to tell you about the system, this boundary and the surroundings. I have already told you that system, what is system, the boundary and the surroundings. Now we'll discuss some of the boundary features. So what is boundary? Boundary are of three types: the open, the closed, and the isolated boundary. The open boundary allows mass and energy interactions. The closed boundary allows only the energy interaction, and the isolated boundary allows no mass and no energy interactions. So simple. We will now tell you, or I would like to throw some light over the facts I will be using to design or assemble the typical air compressor. That is, air moves from high pressure to low pressure region, and the pressure into volume is always constant. Or we can say that pressure into volume to the power of n is always constant, but for the simplicity I've taken n equal to 1. Now we will moving toward our CAD model to discuss further. This is our CAD model. Here we have already discussed about the system, the surrounding, and the boundary. Now we will discuss how this actually works. This is a typical motor, or we can say a 300-volt motor that actually runs via electrical source that can be a battery. There's a shaft which is responsible for the movement or the working of this air compressor. This shaft gets rotated when there is electrical energy supplied to the motor. So this gets rotated. So when this gets rotated, there is a spring, extension spring, that actually get a torque due to the shaft, and when this get a torque, it in turn provides some kind of force to the piston of this cylinder. Now this piston tries to move back and forth, creating some increase or decrease in the clearance volume of the cylinder. Now as we know that pressure into volume is always constant, so when piston moves inside, there is a decrease in the volume. So when the decrease in the volume, that means the pressure inside increases. As we know that pressure inside increases, so the air moves from high pressure to the low pressure region. That's why the air moves out through this outlet pipe. This can be just simply proven to you guys. So there is also an inlet valve that allows the motion of air only inside. So when this compressor piston move outside, it increases the clearance volume, hence decreasing the inside pressure, as pressure is inversely proportional to the volume. So as the volume increases, the pressure decreases and the outside pressure is more. So the air rushes from outside through this inlet valve into the container. So again, this process can be just stated that how the compressor works by a back and forth movement of the piston. This is a typical type of air compressor that you all guys can just assemble at home using a pressure or the inlet valve that can be easily available in the market or the like stores, cycle stores. This is a clear pipe. Piston cylinder arrangement is a typical type of syringe arrangement. Extension spring, that can be, you can also use a cycle spoke, a 300-volt motor that can easily be available in the market. This is how you can create your own piston cylinder air compressor. You can take a great look over my CAD model. This how I hope you guys liked my video. Thanks for watching it. I will be like demonstrating, explaining more engineering stuff to you guys. I will be like telling you about more engineering fun styles. I will be telling about drones, ships, hovercrafts, hydraulic pumps, air drag freewheel cars that are my own concepts. Thanks for watching. Hope you like it.